For over 30 years, NASA has been exploring and investigating the planet Mars. And this has pretty much always come alongside one question. Could it, at one point, support life? And a recent announcement released by NASA, for the first time, really seems to point towards that answer being yes. Today, we are going to go over the results they found and a little bit about what they might mean. I would like to lay some groundwork before we get into this, though. This discovery centers around microbial life, so unfortunately, no cosmic fish. And it is rooted in evidence of life from the past, meaning we won't be discussing the possibility of anything still being there. Even taking this into consideration, though, I found this news to be very exciting, and of course, I wanted to cover it. So with that, let's get started. On February 18th, 2021, the Perseverance rover landed on Mars in what is known as Jezero crater. After around 3.5 years of exploring, it found itself at a spot called Narratava Vallis, which is a river channel that once fed the lake that was found in Jezero crater. Within this area is something called the Bright Angel Formation, and found there is a certain rock formation called Cheyava Falls, and this is where things get interesting. But before we get more into the discovery, let's touch on how NASA handles findings like this. In most cases, there can be more than one explanation for why a finding can occur. What might look like a biosignature at first could also have been formed by a naturally occurring process. So, when NASA makes a discovery that could point towards signs of past life, those results are released to the scientific community and are thoroughly examined and tested. And if a more reasonable explanation is discovered, then the search continues. So what was discovered this time, and what makes it different? Well, we will come back to this second question later. First, let's go over what was discovered. Here, in and around the red mud seen in this image, we can pick out two features of interest. These black poppy seed-like specks, and these white circles that look like leopard spots. But what sort of reaction might have caused these features? And could they possibly relate to organic matter in some way? That is one of the important questions NASA scientists asked. Using the Sherlock instrument on Perseverance, they studied this section here where the black boxes are. What this instrument can do is use spectroscopy to detect things like minerals within microscopic rock features. Found within the spectra that came from this is something called a G band. Now this band is significant because it strongly indicates the presence of organic carbon within the red mud. And this led to the next big questions. Do the spot formations come from an interaction between the mud and the organic matter? Thankfully, there is another instrument on the rover that can help with this. It is called Pixel. What Pixel is a X-ray fluorescence spectrometer, and what it can do is image a surface, right, and create a high-resolution, fine-scale view of the composition of the imaged surface. What it returns is a colored graph that tells us about what is found in and around that area. Seen here on screen is what Pixel took of Cheyava Falls. So let's briefly go into what these colors mean. Red, which is what we see most of, is the mud that's surrounding the features we mentioned earlier, or even that the features are in. What this red color tells us is that the mud is rich in iron. The stuff that is purple is the poppy seed formations we saw earlier, and these are rich in iron and phosphorus. This also appears in the rims of those leopard spots. Now, for the cores of the leopard spots, which are showing up in this yellow-green color, those are rich in iron and sulfur. So each of these pairs, so not the red mud, but the leopard spot pair and the poppy seed pair, have combined to create some exciting minerals that, when found mixed into the red mud, tell a potentially fascinating story. These two minerals in question are vivianite and greigite. Now, here on Earth, when we see this combination of mud and organic matter, it is very often a byproduct of excrement coming from microbial life. So this implies pretty heavily that in the past, in or around this area, Mars might have had living microbes that were eating, metabolizing, and then leaving behind these traces that we are now seeing. So let's connect this back to what we mentioned earlier, and that oftentimes there can be other causes of this. So these findings were released and studied by other scientists and stress tested, and we can actually see the results of this in the paper that was released. I'm going to link that in the description in case you want to read more. But really what makes this time different is, unlike previous instances where there have been other explanations that make more sense, in this case, past microbial life is actually the explanation that makes the most sense. And so that's really what makes this significant, right? Not only is it a explanation, but for what we're seeing right now, and as far as we can study it, it is the explanation. Even with all this, to truly make a final determination will require more study than what the rover can do on its own. And so this really does kind of hinge on the success of the Mars sample return mission, which would collect the samples left behind by Perseverance and bring them back to us here on Earth, where they could be studied even more closely and with equipment that we simply couldn't fly out there. And while that program is admittedly not looking too great right now, as NASA still unfortunately is facing budget cuts, I do hold fast to my hope that the program will go through in the future in one way or another, and that these samples will make it back to us. Because I'd love to see studied results of not only Cheava Falls, but of all the samples the rover has gathered and will gather over its time running. You know, it's great that there are instruments on board that can help us glean things initially and really be selective about what we try to bring back, but at the end of the day, to do true study, it has to be here on Earth. And for that to be possible, we need those samples to come back. And really, like, if they do, who knows what exciting things we might end up concretely discovering for real. So, I hope you enjoyed this. If you do, please give me a like and subscribe. I really appreciate it. Leave a comment. Did I leave something out? Is there something you'd like to talk more about or see more explained more in depth? I'd certainly love to hear about it below. And with that, let us all step outside tonight and look towards the stars.